Okay, so welcome back to another section, still dealing with highest common factors of all numbers. In the previous class, we've dealt with the tabular method. I want to show you how to go with the exponential method. I choose to keep these numbers on the board because I want to use the same numbers for the exponential method. The first question is find the HCF of 6 and 10. We are using the exponential method. We've used the tabular method in the previous class. Let us learn how to use the exponential method. In the exponential method, we shall be dealing with the prime factors of these numbers. We shall be using the prime factors of these numbers. And after having the prime factors of these numbers, we are going to express these numbers in their exponential form or in index form. We're going to express these numbers in their index form or exponential form. So let's start with the first question. Find the HCF of 6 and 10. Solution. 6 is expressed in prime factor form as 2 times 3. And the exponential form of 2 and 3 will be 2 raised to the power 1 times 3 raised to the power 1. That is the exponential form. 10 is expressed as 2 times 5 in the prime factor form. And in exponential form, it will be 2 raised to the power 1. We only have 1 2 here. Times 5 raised to the power 1. You notice that 2 is common in the both numbers, but 3 is not common and 5 is not common. So I'm going to include 3 and 5 in the areas that we do not have 3 and 5. But this time, that 3 and 5 will be raised to power 0, knowing that according to the law of indices of 0 power, any number raised to power 0 is equal to 1. You must have been taught indices. If you have not been taught indices, then go through the class that has to do with indices in U Perfecta online school and have a better understanding about that. Any number raised to power 0 is 1. So since there's no 5 here, I'm going to add times 5 raised to power 0. Since there's no 3 here, I'm going to add times 3 raised to power 0. Now our HCF will simply be those factors that have the lowest powers in the both cases. Those factors with the lowest power in the both cases are what we're going to pick out. For 2, the two of them have the same power 1, so I'll pick out only 1 2 times. For 3, we have 3 to the power 0 as the lowest power. For 5, we have 5 to the power 0 as the lowest power. This is the index answer. The index answer of 6 and 10 is simply 2 raised to the power 1 times 3 raised to the power 0 times 5 raised to the power 0. Or you just tell us the answer is 2 raised to the power 1, because 3 raised to the power 0 is 1 and 5 raised to the power 0 is 1. And 1 times 1 is still 1. 1 times this number is still this number. So our answer is 2 raised to the power 1. But if you're not asked to keep your answer in index form, our HCF will simply be 2 raised to the power 1 times 1 times 1. Our answer will be 2. Our answer will be 2. 2 raised to the power 1 is still 2. So you can see that that is the exponential method of finding the HCF of numbers. The ones with the lowest powers are the ones you pick in all cases. Let's try the next question. What is the HCF of 18, 16, and 20? Solution. 8 is simply 2 times 2 times 2, which is 2 raised to the power 3. 16 is simply 2 times 2 times 2 times 2, which is 2 raised to the power 4. 20 is 2 times 2 times 5, which is 2 raised to the power 2 times 5 raised to the power 1. You will notice that they all have 2 as factors, but only one has 5. So I'll put here 5 raised to the power 0. I'll put here 5 raised to the power 0. So our HCF will be the ones with the lowest power. For the 2's, 2 raised to the power 2 is the one with the lowest power. And for the 5 raised to the power 0 is the one with the lowest power. This is our index answer, or you simply write 2 raised to the power 2 as the final result, because 5 raised to the power 0 is 1, and 1 times 2 raised to the power 2 is still 2 raised to the power 2. But if you're not asked to put your answer in index form, your answer will simply be 2 raised to the power 2, which is 2 times 2, and that will be 4. Your answer is 4 in this case. Now, the last question here is, what is the HCF of 3, 5, 20, and 36? Let's start solution. 3 is just one 3, which is 3 raised to the power 1. 5 raised to the power 1. 20, 2 raised to the power 2 times 2 times 5. Let me keep it in that way for you. And that will be 2 raised to the power 2 times 5 raised to the power 1. 36 will be 2 times 2 times 3 times 3. That will be 2 raised to the power 2 times 3 raised to the power 2. That is 36. Now, if we want to arrange this properly, we have the numbers as 3 to the power 1, 5 to the power 1, 20, 2 to the power 2 times 5 to the power 1, 36, 2 to the power 2 times 3 to the power 2. You notice that we have we don't have all the numbers complete. We don't have a 5 here, so I'll put here 5 to the power 0. We don't have 3 here, I'll put here 3 to the power 0. We don't have 3 here, I'll put here 3 to the power 0. We don't have 2 here, I'll put here 2 to the power 0. We don't have 2 here, I'll put here 2 to the power 0. We don't have 5 here, I'll put here 5 to the power 0. So now we all have 2 in all areas, 2, 2, 2, 2. We have 3 in all areas, 3, 3, 3, 3. We have 5 in all areas, 5, 5, 5, 5. But the ones with the lowest powers are the ones we pick as HCF. So our HCF will be equal to, for 3, the one with the lowest power is 3 to the power 0, times, for 2, the one with the lowest power is 2 to the power 0. For 5, the one with the lowest power is 5 to the power 0. This is the exponential form. Or you can also write it as 1, because all the numbers here are 1. 3 to the power 0 is 1, 2 to the power 0 is 1, 5 to the power 0 is 1. So our HCF is 1. Can you see that? So this is the way we solve using the exponential method. You express them in their prime factor forms and only pick out the ones with the lowest power after completing the factors to be same in all the numbers. You must ensure all the factors are found in all the numbers before picking out the ones with the lowest power. When we will be dealing with LCM, we'll be picking the ones with the highest power. So put that in your mind already. But for HCF, you pick the one with the lowest power. So this is a method known as the exponential method. See you in our